Hello my dear students. So in the previous chapter we discussed why we need to have rate of reactions or why it is important to calculate rate of reactions so that we can definitely compare and say or we can give a better idea, a quantitative idea about the rate of reactions, how fast a reaction can take place. So students, we saw what rate of reaction is. What is it? The amount of change that takes place in a unit time. So what is the amount of change? Either the amount of reactants used up or the amount of products formed. So both are equal, amount of reactants used up and the products formed. So when they take place within a certain period of time, we calculate the rate of reaction. And that can be calculated in two ways. How did we do that? In one, we fix the amount of reactants used up or the products formed, and we observe the time taken for the certain amount of reactants to be used up or a certain amount of products to be formed. Or else, what we do is we fix the time, amount of reactants used up or amount of products formed in a unit time. So since the equation is the change divided by time, we can either fix the amount of change or we can fix the amount of time. So either way, we can calculate rate of reaction. So then I mentioned to you all that there are different factors. We have discussed two factors also before that affect the rate of reactions. So that is what we are going to discuss now. Factors affecting the rate of reactions. So here you can see when a chemical reaction occurs, the chemical bonds between the particles of reactants, that is atoms or molecules. So here the bonds between particles of reactants, it can be atoms or molecules, are broken. Different products are formed as a result of building new bonds. Now I will explain this with an example. Let's say we will consider the reaction between nitrogen gas and hydrogen gas to form ammonia. We have balanced this equation before also, students. So to balance hydrogen, we put a 3 here and 2 there. So then the reaction is balanced. 1 nitrogen gas reacts with 3 hydrogen molecules or 3 hydrogen to form 2 ammonia. Now you know the gases here. You are familiar with nitrogen, hydrogen. Now if you take a nitrogen molecule, you all know that there is a triple bond between the nitrogen atoms. You are familiar with the Lewis structure, students. And there are lone pairs also here. Now hydrogen, there is a single bond between the hydrogen atoms. Then you know the structure of ammonia. NH3, nitrogen-hydrogen bonds, and there is a lone pair. Now look at the bonds. What can you see there? Now there is a triple bond between 2 nitrogen atoms, a single bond between hydrogen atoms, but here you only see nitrogen-hydrogen bonds. So what happens here? This has to be broken, this has to be broken, so bonds broken, and these 3 bonds are formed. So bonds formed. So when the reaction between nitrogen and hydrogen take place, there are chemical bonds which are being broken and new bonds are being formed. Now if you take 2 containers. Now if you have a container with N2 gas. We have another closed container with H2 gas. If you have them close to each other, will there be a reaction? Will anything happen? No. Why? Nitrogen is in one container, hydrogen is in another container. There is no contact between the gas particles. But if you put them both together into one container, you have N2, H2, then these molecules and these molecules are together. When they are together, they collide with each other. There is collision of reactants. So when the reactants collide, bonds are broken, new bonds are formed. So then only the reaction will take place. So for a chemical reaction to occur, that is for the reactants to be converted to products, the reactants have to be in contact with each other so that there will be collision between reactant particles. Then only the reaction will take place. So if we can increase this rate of collision, if more particles collide or if the particles collide faster, then the reaction will be faster. So if we look at the factors that affect this rate of collision of reactants, then we can increase or decrease the rate of reactions. So those are the factors that affect the rate of reaction. So if I go back, so this is what I explained to you. Now, factors under this, when a chemical reaction occurs, the chemical bonds between the particles of reactants, that can be either atoms or molecules, are broken. Different products are formed as a result of building new bonds. Particles of the reactants should collide with one another for this breaking and building of bonds to occur. Is that clear to you? So, if we can affect that, if a factor affects this collision and breaking and forming of bonds, then that factor will affect the rate of reaction. So, under that, factors that affect the rate of reactions are given below. I'll give you all the factors, then we will discuss them one by one. So, the first factor is surface area of reactants. Then there is the temperature at which the reaction occurs. Then there is another factor, concentration of reactants Now that is for liquids or solutions, but if it is gaseous reactants, pressure of gaseous reactants. Then there is another factor, that is a catalyst. So, if we look at the factors that affect the rate of reactions are given below. One is the surface area of reactants. Now, when I explain how we can calculate rate of reaction, I told you all calcium carbonate chips and calcium carbonate powder. So, there the surface area of reactants is different. Now, something you have it as a large chunk of substance. When you crush it, it becomes powder. So, there the surface area changes. That affects the rate of reaction. So, surface area of reactants. Then the temperature at which the reaction occurs. Now, we saw magnesium doesn't react with cold water, it reacts with hot water. So, there the temperature changes, the rate of reaction changes. Then concentration of reactants. When we say concentration of reactants, students, you have to remember when we take a solution. I have explained this to you all in the previous lesson also. Say hydrochloric acid, you have the hydrochloric acid, the pure solution, and you have water. When you mix them together only, you get the hydrochloric acid solution. If the amount of acid is more and water is less, we call it a concentrated solution. If there is more water, less acid, we call it a dilute solution. So, there the amount of hydrochloric acid varies. So, likewise, if you take the reaction of magnesium with hydrochloric acid, you can use a concentrated hydrochloric acid solution, dilute. There also the concentrations can vary. That will affect the rate of reaction. Now, this is for solutions. When we say concentration, it's for solutions. But I told you all, now when it is gaseous reactants, if it is a gaseous reactant, for example, nitrogen gas reacting with hydrogen gas, there we can't calculate the concentration because it's not in the form of a solution. You don't mix it with water. So, there it is the pressure of the gases. Pressure exerted by the nitrogen gas, pressure exerted by the hydrogen gas. That is similar to concentration. So, there basically we consider the amount of reactants, whether there are more reactants or less reactants. That is the concentration of reactants or pressure for gaseous reactants. Then we have the next one, last one. We have a catalyst. Now, you are not very familiar with a catalyst, but in the first lesson, when we discuss biomolecules, you all know proteins form enzymes. Enzymes are made up of proteins. And to observe and understand the activity of an enzyme, we use the amylase enzyme. If you can remember, we put a few green gram seeds to soak, and when it starts germinating, we grind that and get the extract, and there I told you all there is amylase. So, that amylase is an enzyme. Now, that amylase is a biological catalyst, a catalyst present in the living body. Like that, there are some catalysts that are used in chemical reactions also. Now, for example, if it is hydrogen peroxide. Now, you all know hydrogen peroxide undergoes decomposition to produce or evolve oxygen gas. Water and oxygen are produced. For that reaction, either you can supply heat or you can put manganese dioxide. So, that manganese dioxide is a catalyst. So, that is the catalyst. You are familiar with enzymes. Enzymes are biological catalysts. Like that, there are chemical substances that increase the rate of reaction. So, those are the catalysts. So, those are the four factors: surface area of reactants, temperature at which the reaction occurs, concentration of reactants but pressure of gaseous reactants, and catalyst. So, we will discuss these factors one by one. The first one, surface area of reactant. A large log of wood can easily be burnt when it is split into small splints. So, you have a log of wood. If it is a tree trunk, if you cut it, it will be a very large log. If you put that log into the cooker, hearth, it's difficult. One thing, because of the size, you can't insert it, and also for it to burn, it takes a very, very long time and it's not very efficient. So, normally what do? They split it into splints. Those are small sticks, small splints. So, when you use them for combustion, either in the hearth or let's say fireplace, it burns easily. Why is that? When you have a large log, now say if you have a large log like that, the surface area is only the surface area. Let's say it's a cylindrical structure, the top surface, bottom surface and the surface area of the cylinder. But when you split this into small thin splints like that, you will get a very large number of splints. Now, this has a surface area that is also, let's say, like cylindrical structures. So, they also have a surface area. Although it's tiny, it's thinner, if you consider all the splints, the total surface area will be obviously higher than that of a log. So, this is a log. These are splints. Is that okay, student? So, you have a large chunk of something, let's say calcium carbonate. If you have a large chunk of calcium carbonate and if you have powdered calcium carbonate, obviously that will have larger surface area compared to this. I will explain this in more detail with calculations as well. So, that is surface area. Now, here another example. Physicians advise to chew food well for easy digestion. Why do physicians advise us to chew food very well? Now, sometimes you all know in school you all have lot of activities. In addition to studying the lessons, learning in class, you have other activities, extracurricular activities. So, you all are in a hurry to go for that. Sometimes you want to talk with your friends. So, you are in a hurry to do that. You want to play during the interval. But that also you are in a hurry to eat your food. Then what do? You just take bites, you just swallow it and then you run to do your work. But that is not good for your body, for your digestive system. So, always physicians or doctors or even your parents, grandparents, they tell you to chew the food well and eat it. When we chew, what do? We bite the food, we break it into tiny particles and we make it into very small pieces, tiny particles. So, then when that food goes into our body, inside the digestive system, it is easy for the chemical changes. Now, we saw digestion of food is also a chemical change. Why you have the complex food, they are converted to simple nutrients during the process of digestion. So, that occurs faster or easier when you chew the food properly. So, all these are related to surface area of reactants. Then, so we have answered what is the reason for all these. When you chew, when you bite it into small pieces, when you split it into small splints, the surface area increases, so the reaction is faster or reacts better. When a solid reacts with a liquid or a gas, the reaction occurs only on the surface of the solid. The reason for this is that the particles of reactants collide only on the surface of the solid. So, this is important. Particles of reactants collide only on the solid. So, again we will look at the same example. Now, calcium carbonate, a chunk of calcium carbonate. If you have this calcium carbonate here and you have HCl there. Now, this HCl is in contact with only the surface. So, there are only a few molecules on the surface of calcium carbonate. So, those are the ones that are going to collide. But there are so many other calcium carbonate molecules within the bulk of that substance. So, they are not in contact with hydrochloric acid. For them to come in contact, it takes a longer time. At the same time, if you put hydrochloric acid into that, if you put the powdered calcium carbonate, Now here see all these particles, all the particles are exposed to hydrochloric acid. So, lot of calcium carbonate molecules can collide with hydrochloric acid. So, because of that, there will be fast reaction here, there will be slow reaction there. So, obviously, when you have a solid chunk of the reactant, the rate of reaction will be slower. And when you have powder, the rate of reaction will be higher. Why? Because there will be more number of collisions taking place. More reactant particles are exposed to each other. they collide with each other, and because of that, the reaction takes place faster. Is that clear to you all? So, I am sure students, you all can understand this concept. I told you all that I will explain it, how the surface area increases when we break the large chunk into smaller pieces with a calculation. So, that is what I am going to discuss next. So, here there is an assignment given to you. Look at the picture, you can see this is a cube with the side length of 2 cm cube. Consider a cube of marble, that is calcium carbonate. So, the previous example also I used calcium carbonate of a side 2 cm. Put into dilute hydrochloric acid solution. Calculate the surface area of marble that comes into contact with the acid. So, if you do the calculation there. Now, here what is the surface area? Now, this is one surface. Like that, there are how many faces are there for a cube? You all know there are 6 faces. So, each face has a surface area. So, if we calculate the surface area, 2 into 2 is the surface area of one face. So, there are 4 centimeter square is the surface area. Like that, there are 6 faces. So, 6 into 4, that is going to be 24 centimeter square. So, 24 centimeter square there. Suppose that the marble cube is cut into 8 small. Suppose that marble cube is cut into 8 small cubes. A side of each is 1 centimeter in length. So, here this is the large marble cube. You know we can cut it. We can cut it in the vertical plane. We can cut it along the horizontal plane. So, then you can get 8 small pieces. So, each one has a side length of 1 centimeter. So, then again each small cube has 6 faces. Each face has the surface area. What is the surface area there? Here it is going to be 1 centimeter into 1 centimeter. So, there if we calculate area 1 into 1 centimeter square. So, that is going to be 1 centimeter square. So, 1 cube, there are 6 faces. Like here, 6 into 1. So, that is going to be 6 centimeter square. Now, here there was only one large cube. But here, when you cut it into smaller cubes, there are 8 such cubes. So, 8 times 6 centimeter square. So, that is going to be 48 centimeter square. Now, can you all see? When it was just one cube, the total surface area was 24 centimeter square. But when you cut it into smaller cubes, when you break it into smaller cubes, there is 48 centimeter square surface area. So, the surface area has become double. The same amount of substance, the same mass, but the surface area has increased. So, then what will happen? There will be more calcium carbonate particles exposed to hydrochloric acid. So, the reaction will be faster. So, what if you powder it further? The particles will become smaller in size. The surface area will increase further. So, because of that, there will be more collisions and the rate of reaction will increase. So, I am sure you can understand this calculation. But again, in the next slide also, I will do this calculation and explain it again. So, here you can see surface area of one side of the large cube. What is the surface area of one side of the large cube? 2 centimeters into 2 centimeters. So, you get the surface area as 4 centimeter square. I did the calculation before also. Here students, I have substituted with the unit itself. So, 4 centimeter square is the surface area of one side. Surface area of one side. Then there are total area of 6 sides. Because there are 6 sides, the total area of 6 sides. 6 into 4 centimeter square. That is going to be 24 centimeter square. That is the calculation I did before also. Here everything has been written down separately for you all. Then, surface area of one side of a small cube. Now, small cube you know is 1 centimeter side length. So, 1 centimeter into 1 centimeter. So, that is going to be 1 centimeter square. Total area of 6 sides of one small cube. So, again there are 6 sides. So, 6 sides into 1 centimeter square. That is going to be 6 centimeter square. That is the total area of 6 sides of one small square. And the total surface area of 8 small cubes. There are 8 small cubes, each one with a total surface area of 6 centimeter square. That is going to be equal to 48 centimeter square. Again, since I did the calculations before, I am sure you all can remember all the values. So, from this calculation, I am sure students you all can see when you have the large cube 24 centimeter square. When you have small cubes 48 centimeter square. The surface area increases when you break or cut a large piece into smaller pieces. So, accordingly, it is clear that the surface area increases when a large cube is divided into small cubes. It is very important. Surface area increases when a large cube is divided into small cubes. So, like I said before, if you even break the small cubes further, that is if you powder the substance, then it becomes even more surface area. The surface area increases further. So, obviously, that will affect the rate of reaction. Is that clear to you all? So, then we will move on to the next slide. Here we discuss an activity. Activity, let us find out how the surface area of reactants affects the rate of reactions. So, for that we need to use these materials. Like I told you all before students, we will be looking at the reaction between calcium carbonate and hydrochloric acid. So, for that we have calcium carbonate powder and calcium carbonate chips. Then we need to have beakers. You can use one beaker, wash it and reuse it, or you can have more than one beakers at a time and do the reaction. Then on this side we have hydrochloric acid, and you all know normally we use dilute hydrochloric acid, and we need a stopwatch so that we can time the reaction. So, what are the materials? We need calcium carbonate powder, we need calcium carbonate chips, hydrochloric acid, stopwatch, and we need beakers. So, this is what we can do. We can have 2 clean beakers of similar size, identical beakers. Then you can have 2 clean watch glasses. Using those, you can weigh the same mass. That's very important. If you take calcium carbonate chips and powder, they have to have the same mass. Why? The amount of reactants can't change here. Now, when you do these activities, students, we discuss 4 factors. Surface area of reactants, temperature, concentration, and catalyst. So, when we are observing the effect of one factor, all the other factors have to be constant. So, we need to have the same amount of reactant. So, if you take 10 grams of calcium carbonate, you should take 10 grams of calcium carbonate chips. The temperature, we will be doing the activity in the room temperature, so that won't change. We will not be adding any catalyst. So, that is also not a problem. So, temperature and concentration, the mass of the reactants are the same, no catalyst. So only factor that is going to change is the surface area. So one is going to be powder, more surface area. Calcium carbonate chips, less surface area. Then what do? We measure equal amounts, and at the same time we take the same hydrochloric acid solution, equal volumes, into both the beakers. Then what we can do is we can transfer the calcium carbonate powder into one beaker. While we transfer that, we start the stopwatch. So you can get an idea, or you can measure the time taken for the calcium carbonate powder to completely react with hydrochloric acid. After you do that, then again we stop the stopwatch. When you transfer calcium carbonate chips into the second beaker containing hydrochloric acid, again you start the stopwatch. So there also you can observe the reaction and you can measure the time taken for the reaction to complete. So that is the activity. So when we measure the two time periods, you know, I showed you all with an example, a calculation. When you have the equal mass, just the time taken will give you an idea about the rate of reaction. If it is a short time, reaction is fast. If it takes a longer time, reaction is slow. So thereafter, we can even calculate the rate of reaction if we want. But here, we just want to observe the effect of surface area. So we don't really need to calculate the rate. We just need to observe how it happens. So then, if I move on to the method, add equal volumes of acid into two beakers. So you have two beakers here, and into both the beakers you take equal volume of HCl, and that also dilute HCl. Then into one, you put calcium carbonate chips. Add calcium carbonate chips into one beaker. Then you put calcium carbonate powder. So calcium carbonate, both are calcium carbonate. This is chips. This is powder. So what is the reaction? You all know the reaction. And you all know the products also. What is the reaction? Calcium carbonate with hydrochloric acid will give rise to calcium chloride, water, and carbon dioxide. Now that you are familiar with balancing reactions, you all know we need to have 2 HCl. So you can observe the rate of fizzing, and when that stops, you know the reaction is complete. So that is how we observe this reaction. So here you can see, add calcium carbonate chips into one beaker with hydrochloric acid, and using the stopwatch, measure the time taken by the chips to disappear. Repeat the same procedure using calcium carbonate powder. So here students, we measure the time taken. So the amount of reactants used up are fixed. A fixed amount of reactants used up. But we measure the time taken. We compare the rate based on the time taken. So I am sure students, you all can understand this activity clearly. So let's go to the lab and do this activity now. Okay students, so now I am going to do this activity in order to observe the effect of surface area of reactants on rate of reaction. So to do that activity, we need two chemicals. One is hydrochloric acid. We'll be using dilute hydrochloric acid. We have used this before also. And here we have calcium carbonate. So one you can see I have calcium carbonate powder. This is limestone. You all know that is calcium carbonate. So I have one powder, and in the other one I have calcium carbonate chips. So there you can understand students, the surface area of this reactant, that is calcium carbonate, is different. So here we need to take equal volumes of hydrochloric acid. So the amount of the reactant does not change. The same way we will be taking the same mass of calcium carbonate. So in both instances, hydrochloric acid and calcium carbonate, the amount of reactants will not change. And I will be doing the activity at the same temperature. So that also does not change. Only difference is that this is powder and this is calcium carbonate chips. So the surface area of reactants is different. So now to start the activity, what I will do is, I will take the filter papers. In that I will weigh about 5 grams of calcium carbonate. So the chips first. So we will weigh about 5 grams of calcium carbonate. So there I have 5 grams of calcium carbonate chips. I will take that into one small beaker. So now I am going to weigh 5 grams of the calcium carbonate powder. So I have taken calcium carbonate powder as well. We have to make sure that we transfer all the calcium carbonate powder into it. The calcium carbonate chips and calcium carbonate powder. So here students, I will be using 10 milliliters of hydrochloric acid to react with the 5 grams of calcium carbonate. Okay students, so you are familiar with the reaction also. When calcium carbonate and dilute hydrochloric acid react, you all know the reaction, there will be carbon dioxide gas evolve. So because of that, you can observe the bubbling, liberation of the gas or the evolving of gas will be observed. So observe that clearly to understand how long it takes for the reaction to complete. Here students, remember that we are not going to do any calculations. We just need to compare which occurs fast. So as I transfer the solution, I will start the stopwatch as well. So here you can observe. It is a very quick reaction. You can see it occurs very quickly. You can observe the liberation of gas bubbles there. Still you can see the reaction taking place. Here also you can see the evolving of gas bubbles at the sides. So this reaction is occurring. Still there are gas bubbles being liberated, but it has become a bit slower than the initial rate. Now it is 1 minute, but still we can see a few gas bubbles evolving. Now also there is liberation of carbon dioxide gas. So this reaction is still going on. We will need to wait until the completion of the reaction. Still you can see students, there's a small amount of reaction taking place. So now it's going to be 2 minutes. So still there is reaction. But you can see the rate is very, very slow. The reaction is taking place very slowly because almost all the reactants have been used up by now. So you can observe students, it's almost 3 minutes and almost the reaction has come to completion. Only a very few gas bubbles are still evolving. So we can consider the reaction for 3 minutes it occurred and almost completed. Now what I will do is I will keep this aside and I will use the second sample of calcium carbonate, that is calcium carbonate chips. I have it here. And again, I will need to take hydrochloric acid. So I'll stop the stopwatch. So we can consider the time as 3 minutes. So again, we'll need 10 milliliters, the same volume, the same hydrochloric acid solution. So here students, I have taken 10 milliliters of hydrochloric acid, that is dilute hydrochloric acid, the same volume as before. So like I did previously, I will start the stopwatch when we transfer the hydrochloric acid into this. So you all know the observation, there will be liberation of carbon dioxide gas. So you can see the liberation of gas bubbles. So I will start the stopwatch and transfer the solution. So now itself, you all can see students earlier, as I transferred the hydrochloric acid, you were able to see the liberation of gas bubbles. But here you can see it is taking place very, very slowly. So here you all can see students, you can see the liberation of gas bubbles, but it is happening slowly. So from that itself, you all can understand, you can understand the concept. When we use powder, the reaction is faster, whereas when we use the chips, the reaction is slow. So we'll wait for some time and see how the reaction progresses. You can see the evolving of gas bubbles. You can see the reaction taking place. So still the reaction is occurring, but it is a slow reaction. You all can see that clearly. So now you can see students, it's 2 minutes, but still the reaction is going on and at a slow pace. So we will wait for some more time. You all can remember the previous reaction of calcium carbonate powder with dilute hydrochloric acid. It almost completed in 3 minutes. As I said students, we are not going to do any calculations. We are just going to compare how fast the reaction takes place. So that is why I am not writing down any values, just to observe and understand what is a fast reaction and what is a slow reaction, or how the surface area of reactants affects the rate of reaction. You all can still see the evolving of gas bubbles and the reaction taking place slowly. Now it is almost closer to 3 minutes. So it's 3 minutes till you can see students the evolving of gas bubbles slowly. So the previous reaction when we use powder, it was almost over by now. But here you can see the reaction continuing. We'll wait for some more time. So here you can see students, now it is almost 4 minutes is over. So still you can see the reaction taking place. slowly the carbon dioxide gas bubbles are evolving. So from that itself, I'm not going to wait until the completion of the reaction because you have already got the idea how the surface area affects. When we used powdered calcium carbonate, the reaction completed quickly. But now that we use calcium carbonate chips, the reaction is very slow. So when we say powder and chips, when we have something powdered, the surface area, the same mass, the same substance, but the surface area increases because the particles become smaller, the surface area increases. Whereas when we take the chips, the surface area is less. So you can remember, students, for a reaction to occur, there should be collision of reactants, and when the surface area increases, the collision of reactants in a unit time increases. Because of that, the rate of reaction increases. So you were able to observe that and understand that from this activity. With powder, that is calcium carbonate powder, surface area is high, the rate of reaction is faster. When we use calcium carbonate chips, the surface area is less and the rate of reaction is slower. Okay, students. So did you all observe the changes taking place? Yes. So when I use the calcium carbonate chips and calcium carbonate powder, when I reacted them with hydrochloric acid, dilute hydrochloric acid, you were able to see the fizzing. That is because of the evolving of carbon dioxide gas. And also I had the stopwatch. So there you can remember it took 3 minutes for the calcium carbonate powder to completely react with hydrochloric acid. Whereas when I used calcium carbonate chips, I didn't wait till the reaction completed, but over 4 minutes. I waited till 4 minutes and then also the reaction did not complete. So that means when we took the calcium carbonate powder, the rate of reaction was faster. Calcium carbonate chips, the rate of reaction was slower. So that is what you were able to observe. So here if we write the observation, calcium carbonate powder reaction completed in 3 minutes. When we use calcium carbonate chips, reaction continued even after 4 minutes. So from these two observations, what can you conclude? Calcium carbonate powder reacts fast with hydrochloric acid. Calcium carbonate chips react slowly with hydrochloric acid. From that we can say, now powder has more surface area, the chips has less surface area. We have discussed how that is possible. And there, when the surface area of reactants increases, the rate of reaction increases. That is the final conclusion that we can get. So here we can say calcium carbonate powder reacts faster with hydrochloric acid, while calcium carbonate chips react slowly with hydrochloric acid. And also, you all know calcium carbonate powder has more surface area area compared to calcium carbonate chips. So from that, we can conclude and say rate of reaction increases when surface area of reactants increases. So rate of reaction increases when surface area of reactants increase. That is, powder reacts faster compared to the chips. In powder, there is more surface area. In chips, there is less surface area. How is this possible? When there is more surface area, there is more collision between reactant particles. More reactant particles are in contact with each other. So because of that, more particles collide and therefore there is high chances of breaking and forming bonds. So therefore, the rate of reaction is higher. That is what you have to remember, students. This is the conclusion. If they ask you to explain, you have to say, when surface area of reactants increases, the collision between reactant particles increases. So because of that, the rate of reaction increases. So if we look at the observation and conclusion, calcium carbonate powder reaction completed in 3 minutes, whereas calcium carbonate chips reaction continued even after 4 minutes. And from that, we were able to conclude and say calcium carbonate powder reacts faster with hydrochloric acid, while calcium carbonate chips react slowly with hydrochloric acid. And calcium carbonate powder has more surface area compared to calcium carbonate chips. So from that, you can finally conclude and say rate of reaction increases when surface area of reactants increases. Is that clear, student? So that is the first factor that affects the rate of reaction, surface area of reactants, and when surface area of reactants increases, the rate of reaction increases. So if surface area of reactants decreases, the rate of reaction also will decrease. You have to remember that, and you should be able to explain that when surface area increases, the collision between reactant particles increases. Because of that, the rate of reaction increases. So I will write that as a note here. Note: when surface area of reactants increases, the collisions that occur between reactant particles increases. That is why the rate of reaction increases. So this is the explanation. When surface area of reactants increases, the collision that occur between reactant particles increase. That is why the rate of reaction increases. So how does the collision between particles increase? Because there are more reactant particles in contact with each other. For example, more calcium carbonate particles come in contact with hydrochloric acid particles. So because of that, the rate of reaction increases. I am sure you all can understand that. There can be no confusion in this, no? We discussed it with a calculation, we saw the activity, you saw the observation. So you should be able to understand it clearly. So with that, students, I will move on to the next slide. Accordingly, the rate of reactions in those two instances can be ascertained comparing the time taken for equal amounts of reactants to be used up. So here again, we calculate the rate of reaction. So what is it? Rate of reaction amount of reactants used up. Like I told you all before, students, if you have more space, you can write all this in one line. Here, because I don't have enough space, I'm writing it in the second line, but it is just one factor, amount of reactants used up. So divided by time taken. So now that we calculated the time, you all know for powder, now if we weigh the substance, now let's say 10 grams of calcium carbonate takes 3 minutes for the reaction to complete when it is powder. So you divide 10 grams by 3 minutes. Then you get the rate of reaction. Then here of course I did not wait until the marble chips reacted completely. So if you calculate that, let's say it takes about 20 minutes. 10 grams of calcium carbonate chips completely reacts in 20 minutes. Then also you can calculate the rate of reaction. I have shown you all an example before as well. So accordingly, the rate of reactions in those two instances can be ascertained comparing the time taken for equal amounts of reactants to be used up. So one was 3 minutes powder, chips was greater than 4 minutes. So comparing the time taken, we can say powder reacts fast. Chips take a long time to react. So rate of reaction of powder is high, rate of reaction of chips is less. So from there, above activity confirms that the rate of reaction increases when calcium carbonate powder is used. So this is important. Rate of reaction increases when calcium carbonate powder is used. Therefore, it can be concluded that the rate of reactions increase when the surface area of reactants is increased. So rate of reaction increases when surface area of reactants is increased. Surface area of reactants is increased. The cause for this is that the number of collisions between the particles of reactants increases when their surface area is increased. That is also something that I explained to you all. The number of collisions between the particles of reactants increases when their surface area is increased. It is very, very important, student. I explained this to you all. I told you all have to remember this. When they ask you to explain why the rate of reaction increases when the surface area increases, you have to give this explanation. You have to mention the number of collisions between the particles of reactants. They increase when the surface area increases. Because of that, the rate of reaction increases. Is that clear to you all? So then, we will move on to the next slide. So there is an assignment. Surface area of reactants is increased to increase the rate of reactions in day-to-day life. So you all know, now we looked at two examples. One thing, chewing the food when you eat. So when you chew the food, you break it into smaller particles. So there the surface area increases. I told you all, the digestion process is again chemical changes. So that takes place faster. That is, digestion is faster when you nicely chew the food and swallow it. The same way, then using a log of wood, if you split it into small splints, then it burns easily. It burns faster. So there also, when you break it, when you chop it into small splints, the surface area increases. Therefore, the reaction, that is the combustion of firewood, increases. The rate increases. So there are some more examples, or you can think of many other examples where we use the surface area of reactants. That is, we increase the surface area of reactants to increase the rate of reaction. So that is in day-to-day life. Prepare a list of such instances. So you have to do that, students. Now that we discussed two instances, one thing, chewing the food and breaking it into smaller pieces so that digestion occurs faster. Then chopping a log of wood into small splints so that it can burn faster. Like that. What are the other instances you have observed this? Now earlier also I told you all, when we boil a potato. Now you have the raw potato, you know the properties. It is very hard and the chemical substances that are there are different. But when you boil it, if you put the potato into water, if you boil it, it becomes softer and the flavor, taste, everything changes. So there, when you boil the potato, obviously it's getting cooked, and during that process, there is a chemical change taking place. So that is faster when you cut that potato into tiny pieces. You have a large potato, the surface area is less, but when you cut it into tinier pieces, the surface area is more. So you can boil it faster. You can cook it faster. So that is another instance where you observe this. Increasing the surface area, the rate of reaction increases. So here we can say, can cook small pieces of potatoes faster than one full potato. So when you have one full one, to cook that, it takes a little longer time. But when you cut it into say 8 or 10 pieces, tiny pieces, small cubes, it cooks faster. So that again, increasing surface area, we increase the rate of reaction. Then what else? Now the activity we just discussed. Using calcium carbonate powder instead of calcium carbonate chips. So that is another one. But this of course we usually use it in the lab. At home also you can think of many other reactions like that. Now we discussed aluminium with vinegar. Aluminium foil with vinegar. If you react that, you will get hydrogen gas evolving. So instead of having a small piece of aluminium, if you tear it into tinier pieces, if you break it into tiny pieces, then the reaction will be faster. So we can say tiny pieces of aluminium foil will react faster with vinegar. Same way, you can think of eggshells. Eggshells have calcium carbonate. When you break the eggshells into tiny pieces and react it with vinegar, carbon dioxide will be produced. So that will also be faster than reacting the whole eggshell as one. So here you can see, you can say tiny pieces of eggshells react faster with vinegar to evolve carbon dioxide gas. So like this, you can think of many other instances where there is a chemical reaction taking place and we increase the rate of chemical reaction by increasing the surface area. So that is something that you can use. Now even for cooking, there are so many instances where you break things or crush things, powder them so that they cook faster. So there are chemical changes. Is that okay, students? Right. So here, if I show you all the assignment, chewing the food and breaking it into smaller pieces so that digestion occurs faster. Then chopping a log of wood into small splints so that it can burn faster. Then also we can cook small pieces of potatoes faster than one full potato. Then using calcium carbonate powder instead of calcium carbonate chips. So that again for reactions. Then tiny pieces of aluminium foil will react faster with vinegar. That is compared to just one full aluminium foil. Then tiny pieces of eggshells react faster with vinegar to evolve carbon dioxide gas. And also students, now sometimes we have these medications, tablets and the solution. So sometimes the same thing, for example antacid tablets, they contain a base, there is acid inside our body. For gastritis, acidity, we use these antacid tablets. So tablets is a large substance, whereas you have the solution where it has been powdered into fine powder and already dissolved. It is in the form of a solution. So sometimes to get faster relief, it's easier to use the antacid solution and not the antacid tablet. So it depends. That again depends on how quickly you want the relief to occur. So but you all have to remember students, when you are consuming medicine, you have to get the doctor's advice and according to what they say. If they say to take the tablet for slow reaction, you have to use that. If they tell you to take solutions, you have to use that. So we can use this principle of chemical reaction, rate of reaction and increasing the rate of reaction by increasing the surface area. So I am sure students, with that you have a good understanding of how surface area of reactants increases the rate of reaction. So with that, I will end this chapter and in the next chapter, we will see how the other factors like temperature, concentration affect the rate of reaction.